Good morning, dear students. Welcome to our physics class. In the previous classes, we had learnt about force, the various effects of force, the force as a push and a pull, and the two types of force. We had also learnt about the three types of contact forces. Now, in today's class, we will learn about the three types of non-contact forces, then the units of force, the magnitude and direction of force, and finally the addition, subtraction and cancellation of forces. So let us start today's class. I hope you all like it. First, in the previous class I told you about the contact and non-contact forces. So what were non-contact forces? The forces which act even though there is no apparent contact between the two objects. There seems to be a separation, a physical separation between the objects, still the force acts, right? For example, the falling of fruits to the ground. We don't see any connection between the fruit and the ground, but still the force of pull pulls all the this objects towards the ground. Then we also don't see any connection between two magnets, but still the two magnets can push or pull each other. So these are the various non-contact forces, the forces which act even though there is a physical separation between the objects and there is no apparent contact between them. These forces are called non-contact forces. Now, what are the three types of non-contact forces? The three types of non-contact forces are gravitational force, magnetic force and electrostatic force. Right? We will take up one at a time. So first is gravitational force. What is gravitational force? The force with which Earth pulls each and every object towards itself. For example, falling of the fruits or whatever the stones towards the ground. Whatever you push upwards also ultimately falls to the ground. So what happens is the Earth acts as a large magnet and pulls each and everything towards itself. This kind of force is a pull, as it is an attractive force by which all the objects fall towards the ground, right? And now gravitational force can also be called as gravity or the force of gravitational force of attraction. All three mean the same. Right? Now this force was discovered by Sir Isaac Newton when he was sitting under an apple tree and an apple fell to the ground. Then he concluded that there must be some kind of pull which is pulling this apple towards the ground. So this is called gravitational force of attraction by which the earth pulls each and everything towards itself. Now secondly, this gravitational force causes the weight of an object. Weight of an object is nothing but the gravitational force by which it is pulled towards the earth's surface. Right? For example, the weight of a stone is 40 kg. So 40 kg force is applied on that this stone. That is why its weight is 40 kgs. Now you must be remembering that you have learned in earlier classes why the weight of an object becomes very less on the moon. Why? Because the gravity on the earth is much more than that of moon. It is almost 1/6 of that of the moon's surface. Moon is 1/6 less than this. Right? So that is why whenever we want to walk properly on the moon, it is not possible. Even a small step becomes very large. Why? Because the gravitational force of attraction is much less on the moon, which because of which the objects become almost weightless. The weight becomes very, very less, almost 1/6 to whatever it was on the earth. So weight of an object is the gravitational force that it is experiencing. Got it? Now, second type of non-contact force is the magnetic force. If you keep the two magnets at a distance, even then they can push or pull each other. How can they push and pull each other? Is because the like poles of a magnet, what? Repel each other and the unlike poles attract each other. So if you bring the north pole of a magnet towards the south pole of another magnet, there will be a force of pull and both will be attracted towards each other. But if you bring the two like poles towards each other, like north and north or south and south, then they will repel. They will push each other apart. So magnets can cause the force of push or pull, both of them. Repulsion is a force of push and attraction between the magnets is a force of pull. Right? So magnetic force is a type of non-contact force. Why? Because even though the magnets are not touching each other, they can exert a force between them. The magnets also exert magnetic force on the other magnetic substances like cobalt, nickel, steel, iron, etc. even electromagnets have the same property of magnetic force. They also can apply magnetic force on the various magnetic substances. Right? So this was the second type of non-contact force. Now the third type is electrostatic force. Now you must have played with your plastic ruler. What do? You rub the plastic ruler on your dry hair, and then when it becomes charged, what do? You attract the small pieces of paper through it. Now even though you don't touch the scale to the pieces of paper, they rise. There is an attraction between the pieces of paper and the scale. Same goes for a charged balloon. You rub a balloon with a piece of silken cloth and let it go. What will happen? After some time you will see that the balloon sticks to the wall of the room. Why? Because there is an attraction between the wall and the charged balloon. So when you are rubbing two objects together, they become charged. Electrostatic charges are generated, and then these charges can cause a force that is called electrostatic force, which can also repel the objects, and it can also cause an attraction between the objects. And electro means electricity, static means stationary. So charges, the electric charges which cannot flow, which are there on the objects themselves, but they are causing an attraction or repulsion between the objects, are called electrostatic charges, and due to these charges the force which is generated is called electrostatic force, which is again a type of non-contact force because there is no apparent contact between the two objects. You can see in this picture, it's a two pieces of straw or two straws. You can again charge the plastic straw with a silken cloth. When these two straws become charged, when you bring them together, they will repel each other because the like charges are generated on the ends of the straw. That is why they will repel each other. These are the three kinds of non-contact forces. Now we will come to the units of force. See, if I ask you how much force did you require to push a very heavy trolley, fully loaded trolley, you will say a lot of force I applied. Then if I ask you how much of force did you require to pick up a small pencil or a small book, you will say very small force. But these are all vague terms, right? We cannot conclude anything from them. So we have to have some measuring units with the help of which we can determine whether the force is large, and if it is large, how much large it is. We can also compare the two types of forces then. So for this we require the units of force, just like we have the units for various other physical quantities like length, like distance, like speed. The same ways we have the units for measuring force also, right? What are the units now? First unit is kilogram force. What is it called? kgf or kilogram force. It is nothing but the force required to lift a mass of 1 kilogram vertically upwards. For example, you have a polythene containing 1 kg of potatoes kept on the table. You use your hands and pick up the polythene. How much force you required to pick that up? It was 1 kgf. That is 1 kilogram force you required to pick up that polythene containing 1 kilogram of any substance. It can also be if a stone of 1 kilogram is falling on the ground, then the earth is applying a force of 1 kilogram force on that object. That is why it is falling down. This is because of the gravity only that the weight of the object is 1 kilogram. Is it clear? Now, if we want to have some smaller unit, it can again be, we can again have this gram force, right? And what is the relation between 1 kilogram force and gram force? Is the same as the relation between 1 kilogram and gram. 1 kilogram has 1000 grams. Similarly, 1 kgf is equal to 1000 gram force, right? Now we have to relate another unit, which is Newton. Newton is the standard unit of force. Like we have SI units for length also, for distance also. For length it is meters, as you all know. The same ways we have the standard unit for force also, in the honor of Sir Isaac Newton. It is called Newton. So Newton is the standard unit of force, and 1 kgf has almost 10 newtons. It is actually 9.8, but for easier calculations we take it in a round figure 10 newtons. So 1 kilogram force is equals to 10 newtons. So if we replace it by 1 kgf is equals to 1000 gram forces, then 10 newton is equals to 1 kilogram force or 1000 gram force, isn't it? So 10 newton is equals to 1000 gram force. If you happen to cancel the zeros on both the sides, what do you get? 1 newton is equals to 100 gram force, right? Now how do you define Newton now? 1 Newton is the amount of force which is required to lift a weight of 100 gram vertically upwards. Right? This is how you define Newton. The definition is important. I hope you all memorize it correctly. The force required to lift 100 gram of mass vertically upwards is called Newton. Alright? Now, now we will learn about how do we define force. How do we describe force? We describe force by means of two physical quantities. What? Magnitude and direction. Now, magnitude is nothing but a mathematical term which means amount. How much? It can be 10 Newton, it can be 20 Newton, 25 Newton. It is only a mathematical expression. So, this magnitude is denoted by we denote force by an arrow. The tail of the arrow tells us about the magnitude. The longer the tail is, the more the magnitude of the force is. And the head of the arrow tells us about the direction. That means, are we dragging a table away from us, or we are pulling an object towards us? What are we, in which direction are we applying the force? East to west, or west to east, or north to south? Whatever the direction is denoted by the head of the arrow. So this is how we determine force, by magnitude and by its direction. After learning about the magnitude and direction, we will come to realize how can the forces be added. They can be subtracted and they can cancel each other. Now in this topic we will learn about simple addition, subtraction and cancellation of forces. Right? Magnitude being a mathematical expression, we can simply add them up. We can also subtract them, or they can cancel themselves. Now let us see what happens in addition of forces. See, for example, you have to push a table, right? You apply a force of 10 Newton and you push the table. But the table was very heavy. Now what do? You call your friend. And the friend also comes and tries to push the table along with you. He applies a force of say 5 Newton. Now what happens? The table starts moving. The table moved when you both applied your forces. You applied how much? 10 Newton and your friend applied 5 Newton. Now what was the total force acting upon the table when it started moving? It was the sum of your force and the force applied by your friend. That is 10 plus 5 is equals to 15 Newton. So when two or more forces are applied from the same direction, then the net or total force, net means the total force only. There are three terms that mean the same: net force, total force, or resultant force. Now net force or total force is equal to the sum of all the forces acting. But remember, they are all acting in the same direction. So if more than one force is acting from the same direction, the net force will be what? The sum of all the forces. It can be 3 also, it can be 4 also. But whatever the forces are acting on the object, they all will be added up if they are acting from the same direction. But now if they act from the opposite direction, what will happen? Now comes the subtraction of forces. When the forces act from the opposite direction, what will happen? The resultant force will be the difference of the forces. For example, you are pulling a table towards yourself and you are again applying a force of 10 Newton. But now your friend comes and pulls the table from the opposite direction. He applies a force of 5 Newton. So what will happen to the table? The table will move towards you. Why? Because you are applying more force. Right? And how much force is acting on the table actually? It is 10 minus 5 is equals to 5 Newton force. So in this case, the resultant or net force is equals to 5 Newton, which is the difference of both the forces. Alright, understood? So if the forces are applied from the opposite direction, then the net or resultant force is equal to the difference between the forces. And the direction in which the object will move is determined by the larger force. Wherever the magnitude is more, there the object will shift, like the table move towards you. Clear? Now third case is cancellation of force. How and when do the forces cancel each other? Now when two or more forces act on an object from opposite direction, but they are having the same magnitude. For example, you also pulled the table towards you using 5 Newton, and same force was applied by your friend from the opposite direction. He was pulling the table using 5 Newton force, and you are also pulling the table towards you using 5 Newton force. what will happen to the table? The table will not move. The table simply will stay in its place. Why? Why? Because both the forces are having equal magnitude, so they will cancel each other. And the net force will become 0. So when does the net force become 0? When the forces are acting from the opposite direction and they are equal in magnitude. Then the net or resultant force becomes 0. Right? The object does not move even though forces are acting upon it. Understood all of you? So when the two or more forces act from the opposite direction and they are equal in magnitude, the net or resultant force becomes 0. Understood? Now from this we should remember that an object can have more than one type of force acting upon it. Again we will come to the same example I told you. You are holding up say a bucket full of water in your hand. The bucket of water is not falling on the ground even though gravitational force is acting on it. Why is it not falling on the ground? Because your muscular force is not letting it fall. Your muscular force, again acting on the bucket, is counterbalancing the gravitational force that it is experiencing from bottom. So how many forces are acting on the bucket at present? 2. The muscular force in the upward direction and the gravitational force from downward direction. Both of them are equal and opposite, so they cancel each other, they counterbalance each other, and the bucket does not change its position. Understood? If either of them become greater, the bucket will go there. Understood everybody? You want to lift up the bucket now, move it, your muscular force becomes greater than the gravitational force. So more than one type of force. For example, you are running. How many forces are acting there? Frictional force, muscular force, right? And also you can say the sometimes electrostatic force also. So these forces are acting all the same on the same object. So more than one type of force can also act at the same time on an object. You should remember this. More than one type of effect can also be there on an object because of force, and more than one kind of force can also act on an object. Right? With this we finish today's lecture. I hope you liked it. First let us quickly recap it, whatever we have learned today. We have learned the 3 types of non-contact forces, that is gravitational force, magnetic force and electrostatic force. We have learned about the units of force, that is kilogram force, gram force and the SI unit, that is Newton. We have learned what is magnitude and direction of force. Magnitude is the amount of force and direction is in which the force is being acted upon. Then we have learned about the addition, subtraction and cancellation of forces. We have also learned the new term net or resultant force, which is also the total force. I hope you enjoyed it and learned something new today, right? Stay safe, stay at home and enjoy yourselves. Goodbye for now.